Good evening, our honorable lecturer and tutor Ms. Seo. Today we are going to present our MathStory project. Now, I would like to introduce our team members. Our team members consist Alfred Chang, Ling Kai Long, and I Wilson Ong. Now, let's move on to the next slide, which is guiding question. We often ask ourselves, how can mathematics be used in our society? The truth is, mathematics is part of the element for development, providing formulae to solve complex problems, optimize our resources, and other more fields. The next question is, how can we make mathematics more relevant to our lives? And the answer is, we can use mathematics in our daily life, such as formula to calculate the pH value and how to convert complex number into a scale that we can understand more clearly using logarithm. Now, let's move on to the last question. How can mathematics help us solve the most significant problems of our time? Mathematics help us to control data by solving problems that get worse over time, such as producing new technologies to optimize artificial intelligence and data.
What is logarithm? A logarithm is essentially the inverse of an exponent, where an exponent tells you what you get when you multiply a number by itself. A logarithm tells you how many times you need to do that multiplication to reach a specific result. To show you why this matters, let me tell you a story about a farmer. Imagine a farmer whose wet crops are suddenly turning yellow and wilting. To figure out what went wrong, he tests his soil using a pH meter and found out that it has a pH of 5. However, according to his wheat crop guidebook, the optimal pH for wheat is 6, and the sources of getting this information is from Michigan State University. To the farmer, the discrepancy between 5 and 6 might seem like just a tiny difference of 1, but because his wheat is suffering, he reached out for help. He called an agronomist named Dr. Evans. Dr. Evans said that his field tests at 5, the guide requires 6, and worried that his soil is too acidic. Well, Dr. Evans explained that the pH scale is not a standard linear scale, it is logarithmic. She explained to the farmer that going from pH 5 to pH 6 actually means a 10-time decrease in hydrogen ion concentration. This means his soil at pH 5 is 10 times more acidic than what the wheat needs. The formula to calculate pH value is minus log H plus. H plus is the concentration of hydrogen ion. pH plus POH equal to 14.
To find the concentration of hydrogen ions, we reverse the logarithm and we will get H plus equals to 10 to the power of negative pH value, so that we will get the current H plus equals to 10 to the power of negative 5 mole, while target H plus will be 10 to the power of negative 6 mole. So if we divide it, we will get 10, and what that means is it actually is 10 times more acidic than what it should be. Now let's dive into the situation 2. To save the crops, Dr. Evans uses logarithmic function to calculate the exact concentration and pH value of alkali needed to neutralize the soil. To calculate the concentration of alkali needed, we first have to calculate the excess H plus, which we get 9 times 10 to the power of negative 6. After that, we use the formula to calculate out the pH value is 5.046, which is 8.9454 in POH value.
This graph significantly shows the inverse relationship between pH and concentration of hydrogen ion. As the concentration of hydrogen ions decreases from 10 to the power of negative 5 to 10 to the power of negative 6, the pH value rises from 5 to 6. This proved that the soil at pH 5 was 10 times more acidic than the optimal level required for the wheat crops, which is pH 6.
This story shows us that mathematical concepts like logarithm aren't just useless numbers in a textbook. They are vital, real-world tools that can help to solve our real-life problems.
Right, that's all from us. Thank you for your attention, and that's all.